Hi from Brazil. Oh, hi from Boston, Deepak. Hi to Brazil. And now we are also live on YouTube, so welcome everybody from joining us there as well as on the LinkedIn Live. We're just going to wait for a minute or two more, and then we're going to start with our webinar. Hi to Brazil, hi to Chicago. Right. Hello, good morning, good afternoon, and good evening, everyone, depending on where in the world you're zooming in from. And welcome to this Hyperledger in-depth member webinar with Cheesecake Labs. We're going to be started in just 1 minute, just to give more people a chance to join. Okay, I think we are good to go. So hello again, good morning, good afternoon, or good evening, everyone, and welcome to this Hyperledger in-depth webinar with Cheesecake Labs on DLT interoperability with Stellar Connector for Hyperledger Cacti. My name is Tomasz, and I'm an ecosystem manager at the Hyperledger Foundation. And today I'm going to have the pleasure to introduce our panelists, as well as take you through some housekeeping. So first, I would like to emphasize that all are welcome in the Hyperledger community, and we are striving to create a safe and welcoming environment for everybody. So please read our code of conduct when you're interacting with each other on this webinar, as well as in the broader community as well. You can find our code of conduct on our website and on our wiki as well. All of the Hyperledger member webinars are held under the Linux Foundation antitrust policy, and you can also find the antitrust policy on our website and on our wiki. This session is being recorded, and it's going to be available on our webinar library, along with the slides that our panelists will be sharing today, as well as on our YouTube channel under the member webinars. And as mentioned, you can also download the slides from there in PDF format. So if you miss something, you can always return to that later on. This webinar is also being live streamed on YouTube and LinkedIn Live, so welcome everybody joining us there as well. I will post the link there, so if you'd like to register for this actual webinar and ask the questions to our panelists, you're welcome to do so. And you're also welcome to use the chat button on YouTube or LinkedIn Live to post your questions, and we will ask our panelists to answer. We encourage these sessions to be very active and engaging. And the more engagement we have, the better experience for everybody. So feel free to raise your hand, and I will unmute you, and you can speak up and ask your questions. You're also very welcome to use the chat button or the Q&A button to ask your questions there as well. Now, without further ado, I would like to introduce Douglas Silva, CBDO and partner at Cheesecake Labs, and Fabricius Zati, who is a principal blockchain engineer at Cheesecake Labs. We are very much looking forward to this presentation, and Doug and FIFO, over to you.
Thank you so much, Thomas. I believe I can take over the screen share, right, Thomas?
That's right, yeah. I'll just stop it here now.
So let me share my screen. So hey everyone, it's good to see multiple people from different places in the world: Brazil, Colombia, US, Canada. Thanks so much, everyone. We'll have a good conversation today. So a little bit about the agenda for today. Would like to touch on this subject. So we'll start first introducing the interoperability subject with a more broad overview about the challenge around interoperability. Then we'll be introducing the Hyperledger Cacti, and next week also presenting the Stellar Connector for Hyperledger Cacti. We'll also be presenting a demo that we implemented using both the Stellar connector and Hyperledger Cacti. And at the end, that is for all of us to open the mic and have an open conversation around some questions that you folks might have. During the presentation, feel free to send questions on the chat, using the Q&A button, raise the hands for later. The idea is, again, for us to have an open conversation around much of those topics that we know that are very critical to the whole ecosystem, right? And before we do that, just so that I can introduce myself and my friend who's on the call with me representing Cheesecake, I'm Doug. I'm a partner at Cheesecake. I'm also a solutions architect, engineer by background with 15 years of experience. And FIFO is a principal blockchain engineer. He joined most of our blockchain projects at the company. And Cheesecake Labs, we are a decade-old software design engineering company with office in Brazil and the US. And we've been helped from startups to enterprise in the US to either drive digital innovation or to scale digital operation with UI and UX, backend, front-end development, for example. 10 years ago, the company started mainly doing Web2 development, like mobile app development and a few other platforms. But maybe 6 years ago, we started supporting and delivering Web3 solutions. And I still remember, and I mentioned these because I'm very proud of this first project we did on Web3 6 years ago, six-ish years ago, which was an ICO platform for a gold mine in the United States at that time on the Ethereum network. But since then, we evolved lots our expertise around blockchain/Web3. And I add a few highlights here to mention to you folks. The first thing to mention is that we are a Stellar integration partner for a couple of years now, and we delivered lots of good stuff from and within the Stellar network. We're also very proud to be a Hyperledger Foundation member. In terms of networks that we have delivered or we can deliver solutions at Cheesecake, I can name a few. Between those, Hyperledger, Fabric, Bezu, and of course Cacti that we'll be talking with you today. Stellar on both Classic and now Soroban, Cardano, Ethereum, Polygon, and a few others EVM compatible networks, and also Solana. In terms of solutions we have delivered, there are many great use cases that we deliver next to clients in the US. But I have summarized here in a few bullets on things that we did most. So we do lots of consulting around blockchain. So companies who need help to understand what to build with blockchain and what is the best architecture to deliver that solution. Cheesecake was a great ally for some of those clients. We did a few asset tokenization platform and projects on those networks. We do smart contracts implementations. We deliver DeFi solutions and also a bunch of digital wallets. On the digital wallets subject, like one use case that I want to highlight here that might be already well known for some of you is the Monogram no custodial digital wallet that should be launched on Q3 of this year, meaning this quarter. That was entirely built and still is entirely built with Cheesecake Labs from the beginning, like UX and UI to full development of the platform of the mobile app. On this case, a no custodial digital wallet for that huge company. This will really change much of our ecosystem for the good, right? But dive deep into the subject already, like talking about interoperability, like we all know how fragmented our ecosystem is, right? We have many networks, we have many applications, and they are somehow isolated one from the other, right? We have big bubbles rotating on the ecosystem, but they're very isolated, very fragmented one from the other. Especially if you think on the user perspective, right? User perspective that wants to achieve one specific goal, I might need to go over, I don't know, 3 different platforms, create 3 different wallets, and somehow breed 3 different ways so that I can achieve my overall goal. So that's very frustrating for the user, right? And very limiting on what they can achieve using those great solutions that we have out there. And we understand that each network has its ethos to handle security, privacy, governance, and a few other aspects. And to be fully honest with all of you, we don't believe in the concept of having a single chain to do it all or to rule them all, right? We understand that each network is solving a different problem, is trying to deliver good on one aspect. It's again, it's there for a purpose, right? It's fulfilling a specific purpose. And this is good for the ecosystem, right? So with each network in each community focus on different challenge, that's great for the ecosystem because it's really help us achieve more. But again, instead of silos, instead of having these big bubbles operating isolated from all of that, we should be looking for ways to create connections between all of those bubbles. Because only by creating those connections is that we truly believe that we expand capabilities for all of those networks. So those networks or those solutions, they shouldn't see each other as competitors. They should see as, again, a different player in the market that can solve a different problem. So if we can connect together, we can achieve much more than being isolated, for example. So that's why we truly believe that the ecosystem should continue evolving and growing as it is right now, but it should be more connected, right? So things should be working more close and integrated. And we all know how challenging it is to integrate to the traditional infrastructure already, right? In some cases, it's even impossible to integrate the traditional infrastructure, finance and a few other like logistic and some other big infrastructure already in place. And we are crafting the digital space from ground zero, right? We're building the foundations of all of this right now. And we should not allow that to happen on the digital space. We should not allow that digital space that we are building from scratch right now that bring so many effort not to be connected because this will be so frustrating, so limited that doesn't make sense, and this will not be helpful for anyone in the future. And at the end, this buzzword that we heard a lot, that we hear a lot, that we speak a lot, should not only be a word. It should not only be a word that we write an article, that we do a webinar about it, but should be a call to action, for us to do stuff, for us to start using that and implementing interoperability use cases, projects, or connecting with different networks. So it should be a reality, right? That all of us are building. And this is where Cacti came as a great ally into all of this. Cacti is an interoperability framework maintained by the Hyperledger community. It's a graduated project, so it's there and is stable enough for us to start using. And I have added to this presentation one specific link that you folks can take a look later of one article. This is not the most recent article. It's actually maybe the first or second article about Cacti on the Hyperledger community. But the good that I think about starting on this article is that this article not only introduce the Cacti or the framework itself, but talks about the design around Cacti, about some decisions that we're taking while creating this framework, while merging two different projects. That it was how everything started. So I really believe everyone should be reading these, and of course all the documentations. And we'll be speaking about some key aspects of Cacti. But the ethos, if I can repeat that word that I mentioned before, like the design of the framework, it's incredible, right? And at the end, it's a framework, right? So it's a bunch of tools, well designed to work together so that we can deliver interop use cases or interop projects. But FIFO, I would like to ask you to jump into the call and maybe go deeper into Cacti and explain a few key aspects of it.
Awesome. Thanks so much, Doug. And I apologize, guys. My camera just shut down because of overheating. So I'll try to turn it on again in a moment. But to start talking about Cacti, Doug did a great introduction. The framework, as he mentioned, is big and very powerful. And before we get into how it is built and what are the key aspects of it, I want to talk a little bit about the challenge or the space that we are trying to cover here. What are the obstacles that we're trying to overcome with Cacti? Because I think these are very important to understand why it's so powerful. So I'm borrowing some diagrams from the Cacti white paper. And if there are other tech nerds like me here that like to dive into this subject, I highly recommend to go into the repository to read the white paper, because they did a very thorough research on the different aspects, different use cases, the different realities, and how we can find creative ways of solving these problems. So it's a very good reading, and I highly recommend those. So I will start by trying to share at least two main axes of the problem that we are mapping in here. The first one it's covering the P levels for the potentiality, what you're seeing on screen right now. You can see the arrows for P1 to P2 to P3 and P4. And you can think of those as basically the size of the gap that we're trying to overcome when building a solution that connects two different systems or two different applications or two different realities. So in the P1, if you look at the top left corner, you see that we're trying to connect two functionalities that are on top of the same subnetwork, which is on top of the same DLT network, which is on top of the same DLT protocol. What does that mean? In terms of blockchain, you can think of both functionalities being within the same DLT protocol. So Ethereum protocol, the way validators validate blocks and validate transactions and connect everything together, they are on the same DLT network. So the same registry, the same space in which we are storing information, storing data, and within the same subnetwork. And when you think about those, one example could be two smart contracts that connect to each other to create a use case. So for example, if I have a smart contract that manages, let's say, collateral for insurance, and another smart contract that manages loans, we could have a use case in which the loan smart contract checks for a collateral in the insurance smart contract and allow people to take a loan on based on that collateral. So that's kind of a small gap to cross because they are in the same environment, they are playing by the same rules, the same technology. So it's a much simpler space to navigate. And in order to cross these gaps, we need less steps. So our recipe to connect this solution should be simpler. And as we take steps further, let's jump to P2. Now we're talking about two functionalities, but within different subnetworks. So we have a bigger gap to cross. So we might have to add additional steps to make sure that not just the two contracts are interoperating, but they are communicating through these different subnetworks. This could be as we move forward to P3, we take another step further, and now we're talking about different DLT networks. So we could say like a mainnet and a testnet and so on. So even if they have completely different registries, they're still playing by the same rules, the same protocol. And with P4, we talk about two completely different creatures like oranges and bananas, two different fruits. We are talking about different technologies, different networks. They behave completely different. One might have a settlement time of 10 minutes. The other one might have seconds. And when we need to orchestrate that, the challenge becomes very variable. A metaphor that I like to bring into this one for non-technical people is imagine that you have a banking system that only moves cash physically. And I want to make a transfer to a different account. P1 could be for me sending money to Doug, and our accounts are within the same branch. So they only need to take money from one vault, walk around, and put money on the other vault. So that should be very simple to look at both vaults, see if the balances match, if everything's working fine. But now let's say I want to move to someone in a different branch. They would have to pack that money, travel to a different branch, take the money there and verify, go back, inform everyone that it happened. So we are adding extra steps. And as we move to P4, we can even think about a cross-border settlement in which I would have to go to a different country, go through the border, talk with the officers and see if I can cross the border with the money, take it to the different bank system. And if something happened throughout the way and I cannot, for example, cross this border, I cannot just stop. That would be a problem. I cannot just leave the money there at the border. I need to go back and I need to revert all of my steps to make sure that I go back to the initial state. And that's very important because when we talk about this interoperability between different systems, it means that we are trying to make an atomic transaction in a sense that either everything happens or nothing happens. I cannot stop in the middle. Stopping in the middle is a problem. I could be doing a double spending, generating money, destroying money. I could create a big problem. So a portion of the space of what we're trying to solve is understanding this gap and understanding the kind of recipe I have to apply to cross the gap safely and not stopping in the middle. So moving to the next one, Doug, please, could you please jump one slide? Thanks so much. You can think of this one as a completely different axis. Now we're looking for compatibility. So we have system 1 on the left, system 2 on the right, and you can look at the first layer as, let's say, more of a technical challenge, like can both systems connect? One simple example could be I have a credit card system and I have Amazon that delivers packages and has a store. So I could have like the payment system being used to cover the payments and the Amazon system to doing the deliveries in the package. So do they have protocols to interoperate? so that one can handle the payment, so the other handles the delivery? Do they have the interfaces in place so that both can communicate safely, exchange message safely, and coordinate these actions? And do we have the business logic in place to orchestrate everything on both sides? Yes, we do. Okay, so we meet C1. We have the C1 level of maturity in these two systems. Now, as we take one step further and go to C2, now we look at the organizations, and this is a bit different. Now it's not a matter of if the systems can be connected technically. It's more in the sense of, do the organizations have an aligned vision that makes sense to connect their use case? So do their goals align in a sense that the payment company, the payment system wants to handle the payments, and the delivery system wants to handle the deliveries, and both can match in one unified use case? Yeah, that makes sense. And do they have the agreement in places to coordinate that? Like, for example, the credit card system could say, hey, I'll handle the payments for you, but I won't process payments for selling guns. That's against our policy. So they could have an agreement to say, okay, we'll coordinate our operation. We can technically do that, but we'll avoid selling guns when processing the payments with you. So the organizations need to align together to come to a unified use case. That will be C2. And on C3, we're talking about the environment they're acting. So one corporation could be under the Brazilian legislation, and the other corporation could be under the US jurisdiction. And they could come together and see, okay, we have the technical requirements on C1, we have the common goals on C2, but now in order to connect our use cases, we need to make sure we are not breaking the laws. We are meeting all the requirements on both legislations. And if something doesn't align, it doesn't matter if we can technically connect and we want to connect if the jurisdiction does not support that, if we cannot meet the jurisdiction requirements. So you have to take all of these into account when building a system, because it's not just the technical challenge, but all of these other layers that you have to connect together and think on how to achieve this level of compatibility. So when you put those two together, Doug, could you please move one extra slide? Thanks so much. You come to kind of a map of what are you working on, what kind of problem you're trying to solve. So if you combine, for example, here, I want to make a interoperable scenario with Stellar blockchain, the Stellar network, and a Bezel chain. It will be a potentiality of P4 because they're two completely systems. They work with two completely different protocols, and the compatibility could be a C3. Let's say both are under the same regulation, the same legislation, or at least incompatible regulations. So, all right, now I know the space I am acting on, and now I can start thinking about how am I going to build the solution. So as we move forward, Doug, one extra piece. Thanks so much. You're amazing. So moving forward, we have different ways of building these recipes. And something I really like in the Cacti approach is that they lay down these interoperability modes, which are kind of the starting points so you can think of your recipes in a clear way. There is definitely not one size fits all solution, because every use case is unique in a sense. So you always have to think about the different flavors of how you're going to build this. But they are good starting points so you understand what is the complexity or what kind of orchestration I need to add to my system in the middle. So here in the first one, they call it the data transfer. It's basically moving data from one side to the other. When would that apply? Let's think of, for example, a Ethereum market that wants to sell tokens or provide some kind of portfolio rebalancing based on the volume of Bitcoin transacted in the last hour. So we would have a system in the middle that would look at the Bitcoin network to see what was the volume every hour, collect this data, and input this data into the Ethereum network. So what is the kind of recipe you need here? You need to orchestrate the step to look into one blockchain, to bundle this data, create a transaction, and process this transaction on the other network to input this data. This is kind of simple. If you think that you don't have to cross-reference a lot of data, you could have different flavors with a both ways syncing of data. Like, for example, I'll collect data from both networks, I'll process this data, and I'll re-input this data on both networks to coordinate actions. So that will be more complex. And it's a good starting point for a certain set of use cases. Some some guys that use this a lot, and I really like to look as a reference, are the Chainlink guys. Like they have these great Oracle solutions that are using the broader ecosystem. They have these chains of oracles that are bringing external data from the real world and inputting into the blockchain. So you could think of a Cacti framework being used to orchestrate these steps of gathering this data and inputting the data on the target blockchains. Okay, so moving forward, the next one, it's about asset transfer. This is very common. A lot of the DJs out there might have used it a lot in the past. So basically, I have a representation of some sort of asset on one side, and I want to move this representation to a different network. So I want to have my asset on another network. Like for example, Bitcoin exists in the Bitcoin network. So how can I use Bitcoin on the Ethereum network? There are also different ways people tackle this problem. And one of the common ones that's represented here is wrapping an asset. So for example, they would get the Bitcoin on the Bitcoin network. They would lock that asset in a safe way, generate some sort of proof or evidence that it's been locked. And based on this evidence, they would generate a representation of the Bitcoin on the Ethereum network that is tied to that representation. So people can use this representation on the Ethereum network. And once they want to redeem, they just destroy the representation, generate a proof of that, and then they release the original asset on the original blockchain. There are other ways of doing that. You don't always need to lock an asset. Like, for example, something closer to a CBDC approach. You could basically manage the supply and destroy units on one side and recreate on the other, making so that the asset actually jumps from one network to the other, and you don't have like locked supply. You have just one moving representation of the asset in different networks. And when orchestrating a case like this, now you have to coordinate actions on both sides that are really tied together to come up to one result. Like, hey, I really need to make sure I lock the asset on blockchain A. I need to generate this evidence. I need to generate the representation on blockchain B. And I need to make sure that both are cross-referencing each other. So people know that the reference is representing the token that is locked on a certain account and vice versa. And I cannot stop in the middle. I cannot generate a representation without locking the asset, either or I will be just creating new asset and making the supply run on both sides. And I cannot just release the original one without destroying the representation. So this is the kind of challenge you have to orchestrate when doing an asset transfer. For the next one, we talk about asset exchange. And this is really talking about two completely different assets being transacted. Like, for example, in Chain A, I have Bitcoins, and I want to use these Bitcoins to purchase some bonds on the Ethereum network. I'm not moving the Bitcoin to Ethereum, and I'm not moving the bonds to the Bitcoin network, but I'm orchestrating a safe recipe so that I can pay someone in Bitcoin, and this person can give me the bonds in the Ethereum network in a safe way that we can trust it's going to happen. I'm not going to have malicious actors like taking the tokens from anyone or not giving the bonds. And it's the framework in the middle that orchestrates all of these steps to make sure they're happening in a safe way. So you can see that with just these three examples, we have very different ways of building these recipes. And these can evolve into very complex or simpler solutions depending on what you're trying to achieve. So with this one, let's move forward one. Yeah, thanks so much, Doug. Please don't feel overwhelmed by this image. I promise I won't go too deep on the technical side. It's just to comment on a specific element of the Cacti framework. So the Cacti framework, as Doug said, is a big framework. It contains a lot of features and tools that help navigate the whole problem I've just been talking about. So it helps you navigate the different sizes of the gaps. It helps you communicate with different networks that use technologies that are unique and don't always behave in the same way. It helps you coordinate for different protocols. So one network might take 10 minutes to have a confirmation. The other network might take a few seconds. It helps you build all of those in a very composable way. In the architecture that the Cacti implements, they are very composable. All of the components can be used in combined way or in isolation. So drawing attention, for example, to the connector in the middle, which is the main one we are going to talk about today. The connector is sort of the translator of the framework. You have one connector for each network, and the connector is the guy that speaks the language the network speaks. So it is the portion of the system, the tool that knows how to speak with a specific blockchain, a specific network, specific system, knows how they run transactions, how they sign transactions, how they validate these transactions, how long it takes, and it carries on this heavy load. And for the developers out there, you might be noticing the different representations here. You can use the connector in isolation. You can deploy it as a standalone service and use different APIs to connect with this. And you can either just import it as an NPM package into your project and use it directly. So it's very versatile. And most importantly, the framework is agnostic. You don't always need to build a cross-chain interoperable solution. You can just borrow some of these components and use in your own solution. So if I want to build a solution for the Ethereum network, I can just borrow the Ethereum connector, and I'll have a ready-to-use way to connect and interact with the Ethereum network without caring about the other components. So that's very powerful. That's why building a framework like this in an open source approach and in a composable architecture is very important, because every time we build something, we test something, and we improve on top of a component in the Cacti framework, we're helping the ecosystem at scale. So other companies, other entities can use these implementations in very unique use cases. And we have the other components. I won't go through all of those, but you can see, for example, the small green box in the middle called Business Logic Plugin. It might look small, but it's very big and important. That's a way of isolating your business logic in a way that doesn't matter what is the blockchain you're using. You have a clear recipe on how to perform those actions that I mentioned. So I want to do an asset exchange. I have a clear recipe on how to managing the asset on one side, generating the proofs and the locks and verifying the information, and doing the orchestration on the other side. And if something goes wrong, how should I revert each and every step of the recipe in order to go back to the original state? And since these are agnostic to the networks, they depend on the connectors to talk to the networks, you can really reuse these across different solutions and across different environments. So the more companies, the more entities, the more use cases we build on Cacti, the more robust and easy it is to tackle other use cases and other environments. So that's what I want you guys to take with you in your mind. Like, the importance of this framework is not that it is one solution that you use in one way, but it's a big framework full of different components that can be used to build a big use case, or just to borrow some very unique and battle-tested functionality to bring in your application. So that's very, very valuable. Moving forward, Doug, I'll just touch on this one. Oh, I think we jumped one slide. Do we have one prior to this? Oh, there you go. Thank you. So just to touch on this one, is to exemplify that you can also take different flavors of how you deploy your application. So here, it's a simplified view in which you have the blue arrows and the orange arrows. Blue arrows is like one approach, and orange arrows is a different approach. With the orange arrow, you have one standalone application, the node server, which is, think of it like one entity or one company controlling both ends. They're controlling the whole use case to bridge something from chain A to chain B, and they can simply combine the components and build this very easily with the framework to handle the whole use case. Now, if you want to do something with different entities, like, hey, me, FIFO, here in Brazil, I am specialized in working with the Brazilian markets and the Stellar network, and I want to connect with Doug, who works in the US and specializes in the Ethereum ecosystem. That's perfect. I'll handle my solutions here with my standalone and relay, and I'll connect with his solutions, and everything will be well orchestrated through the framework to make sure we are following the same rules, we are communicating in a safe way, and we are getting to the point that we want, which is an interoperable and seamless solution. So that's very, very powerful. And as we move forward, the last one, I promise, don't get overwhelmed by these diagrams. I'm not sure why the Cacti guys really like these big diagrams, but they're awesome to exemplify complex use cases. We have here, sorry for the dramatic pause. My headphone just shut off. I'm not sure what's going on with my gear today. They don't want to participate in the webinar. But in summary, we have here different networks being represented. We have a public permissionless network like Ethereum. We have a permissionless network like Fabric running on a private environment, probably, and we have Corda on the bottom, and you can have any kind of solution or blockchain, and then they're connected through different ways. You see in the middle, you have data sharing, asset exchange, asset transfer. You have those different modes implemented in different ways. You have just one connection of node serve with asset exchange. You have two relays interoperating between the networks for data sharing. You can also connect to an enterprise system. You can connect to decentralized identity registries. So you can really borrow from those components, create a unique use case, like using Lego pieces to overcome a specific problem, and deploy in different environments. And as the framework grows more over time and improves over time, we can get more and more people coming with very unique use cases. And we don't have anymore the silos of separated chains that only work with certain scenarios. We have a more seamless experience for the end user that can trust on specialized chains for specific actions, but also be connected to other chains on different sides of the world. So I think that's very powerful. And what did we do with this project? Before we move into that, just one extra slide, Doug, please. Yeah, I invite you all to scan this QR code. We are going to share the presentation as well. But here's the main link to get to the Cacti page, the main page, where you can find more about the project. You can find a lot of documentation. You can find a lot of past recordings of the sessions going over the features and demos. But most importantly, I urge you to connect to the community. They have the Discord link. The community is very, very welcome. And a big shout out to Peter and Rafael. They were very helpful throughout the whole process while we developed the connector. They have these great standards of running pair programming sessions every day. So every developer that wants to get into the project or know it better or get over the initial hurdles can go in there, just jump into a channel, and you get with these guys through a session to help you start with the project. And this is amazing. This is just amazing. I can't recommend it enough. If we get some extra time at the end, I can talk a little bit about the experience, but let's move forward to what we actually did with the framework. So Doug, could you please take over? I think I froze.
Yeah, I think Duck might have frozen.
Oh, damn it.
Yeah.
Let me see if I can hijack the presentation from this side.
Let's see.
Since my gear has not been helpful, I wasn't sure if it was me or Doug.
I see.
Let me just get over here and open the slides. Let's see if I can share my screen.
Okay, I think Duck has dropped. Probably he's trying to reconnect.
Okay, so while he does that, I'll just move through his part.
Okay.
Let me switch here. Let me see if that's the
Mhm.
right window. Probably. Can you guys see the window where I stopped in the
Yes.
same presentation?
Mhm. Yeah,
Awesome.
exactly.
So I'll just continue through his part.
Okay, great. Thank you.
Awesome. So moving on, what did we do? As a starting point and a no-brainer when working with Cacti, every network that we support requires a connector, which is the translator that knows the network and translate these messages and how to integrate with it. So as Doug mentioned, we worked with a lot of networks. We have a very rich experience with different technologies, and we wanted to bring a little bit of our expertise in Stellar to the Cacti project. So we started by building the Stellar connector. So the Stellar connector, it's basically one of those components that is specialized into talking to Stellar, handling the Stellar use cases, and helping anyone build in this ecosystem as well. So as we move forward, Stellar has some very unique ways of connecting and of managing assets and managing their transactions. So we chose to use Serba, which is a very new environment they created for smart contracts, just came out this year. And we wanted to bring a welcoming way of developers to connect with the ecosystem with something that they're familiar with. So it's kind of the same way of building the recipes and building the solutions. In the future, we want to improve and bring the classic way as well, which I think is going to be very rich to get scalable, cheap transactions. Oh, I see Doug just joined. Doug, would you like to take over again?
For sure. It looks like it's not only your gear, so I did a more long dramatic pause. So sorry about that, but hoping I'm back right and you cannot hear me. Before, as you presented the screen, I believe you can continue, and then I can just take over from where you left,
Okay.
if
I
that's
was just
okay.
introducing the connector. Do you want to get into
Perfect.
the use case right now? Or should I
Yeah,
continue?
that would be great. No, yeah, that would be
Okay.
great. And just something that I mentioned, I was mentioned before, like the cacti, it's great, right? It's made of so many like great
I think we lost Doug again.
Was it me or Doug? It's Doug.
I think it's Doug. Yeah.
It's okay. I'll just continue. I think today my internet is working better than his. Sorry
Okay.
about that, guys. I'll just continue. So what did we do? We started with the connector, and the connector is a great component, but it's hard to exemplify for people. What can you do with that?
Pieces,
So,
like we have those
oh,
key
there you go.
components like connectors, the business.
Doug, are you back?
Okay, I think he's out again.
Yeah, I'll just
Maybe you
continue
should, continue, and I'll just message Doug. Yeah.
It's fine. Sorry about that, guys. So basically, what we built was we had the connector, and we could now interact with the Stellar network. We could interact with it through the Cacti framework, but we wanted to take a step further. We wanted to put it to test and build an actual use case while thinking about the real world assets and real use cases. So some of you might be familiar with the Drex project in Brazil that is going to use Hyperledger Besu to experiment with a CBDC here in the Brazilian ecosystem. So we have been running a lot of experiments with Bezo and connectivity, and we wanted to test that with the Cacti as well. So what we did is that we borrowed from an older demo that existed in the Cacti project, which was a demo for a cross-border asset exchange using Bezo and Fabric. And on the right side here, you can see we have a Stellar side, and on the left side, we have the Bezo. So what we did is that we took out the entire Fabric portion, and we implemented the Stellar portion for doing that. So on the bottom, we have the connector talking to the blockchain. We created some smart contracts in Rust to carry on specific actions on the Stellar network. All of these are in the project. And then we created the gateway that connects with the Bezo side and orchestrate all of these steps. So in this demo, we have two users that want to move an asset from one network to the other and transact on both sides and play around with those tokens. This older implementation that we took uses the SATP, which is a secure asset transfer protocol that is being discussed with the IETF. If I'm not mistaken, Rafael is the one leading these. I'm not aware of the current state, but I know they have been having great advancements in this protocol. And I highly recommend you have a look into it. It's very powerful. So what we did in here is that basically we wanted to play a use case like this. Let's say we have Alice and Charlie, and Alice wants to send some funds from her Stellar account to Charlie, who is using a Bezo account on a Bezo network. So how can Alice cross this gap? The way we do it, Alice sends some funds to a bridge, to an application, and this bridge has an account, and we have smart contracts that manage this process. And she generates a lock. She escrows these funds on the bridge and gets a unique identifier, some sort of proof that this asset has been locked. So with this, she takes this proof, goes to the bridge in the other network, and use this proof, this identifier, to generate a representation on the other network. So that means on Stellar, her asset is locked, safety locked, and this lock is pointing to the existing representation on the Bezo network. So while this representation exists on Bezo, the lock cannot be removed, and it's only going to release the original assets once the representation stops existing. So Alice gets this representation, and she then shares with Charlie. She sends some tokens to Charlie on the Bezo network. Now on Bezo, Charlie can use the token as he wish. He can use DeFi applications. He can share with other people. He can transact normally. And when someone wants to bridge back the asset, they just need to go to the bridge and say, hey, I want to redeem the original one. So the bridge is going to orchestrate the destruction of the representation and the release of the original funds on the original network. So even though Alice was the one sending the tokens to the other network, creating the representation, Charlie can be the one redeeming the asset on the original network and getting the token back on Stellar. So that's what we're going to show in the next few screens. Let's hope the GIFs play. So in this screen, here in the first step, we're just setting up the accounts. So we are just minting some units of the token to Alice. On the left, we have Stellar. On the right, we have Bezo. And here's just to exemplify that this is a normal token that you mint, you transfer, you can do movement for different accounts. So here, Alice has 1,000 units, and then we send 500 to Charlie. So now it's just repeating. And down below, you'll see we have this bridge account, which we're going to use in the next step. So here in the next step, Alice is holding 500 and Charlie too. Alice is going to escrow 250 units. So when she does that, we are using the bridge to send the funds to the bridge. You can see that Alice now holds just 250. The other 250 are in the bridge. And in the next step, she will confirm that she wants to do the transfer. Now, before I move to the next slide, I want you to pay attention down below here. Alice is going to send 250 to the bridge and Charlie too. So once they do that, we get this ID, this unique ID below for each one of the escrowed amounts. So the bridge tracks individually these different scrolled amounts and these different references to ensure that as many users as you want and as many accounts as you want can interact with it in a seamless way. So they're creating these different escrowed amounts. So in the next step, now it's time to move the asset to the other network. So Alice selects the escrow amount she has, 250, and she say, hey, I want to bridge to Bezo. And that's very quick. There you go. So Alice just sent 250. You can see that the Bezo side is going to receive 250 tokens, and these tokens are the representation that are backed by the value that we have here in the bridge. So you see the bridge here has 350 tokens. 250 are fully locked because of the representation, and the other 100 are representing the escrowed amount from Charlie that he didn't bridge, but is there waiting to be bridged or to be redeemed if he wants, because it's not locked yet. So once Alice has the tokens on the Bezo side, she just can use it as any normal token. So what she does, she fractionalizes and sends some units to Charlie. So now she's going to choose Charlie on the Bezo side and is going to send 150 units. So she'll do a normal transfer. Charlie received it immediately. And now Charlie can choose if he wants to escrow some amount and bridge back. So that's what he's going to do. He's going to do the same process on this side. The only difference is that on this side, once you select the bridge back, instead of locking the asset, you're actually destroying this temporary representation. And the bridge sends the funds back to Charlie on the original network. So here you can see, before they do the step, the bridge has 350. And once Charlie confirms that he wants to send the 150, they are going to appear in Charlie's balance and be moved from the bridge after the representation is destroyed. It's very fast. It happens very fast. But under the hood, we're talking about dozens of transactions, dozens of steps, a lot of communications between these two systems, and signed communication to make sure you're talking to the guys you're expecting to talk, you're coordinating through the steps, and you're verifying each step you take in the process to make sure the recipe is being followed. And if something goes wrong, they just make sure to undo the recipe and go back to the original state. I know it looks simple, and we wanted it to look simple, but bear in mind that you have a lot of things going on under the hood, and that's what the framework does. It abstracts the complexity and it simplifies the way of building the solutions. And it's crazy to think that we were able to build the connector, build the whole test ledger that we didn't even mention it yet, and we built this whole demo use case in less than a month. So that was amazing. And it was only thanks to the help from from Peter and from Raphael, and for everything that has been built already in the framework. So moving forward, Doug, would you like to take over from here? I see you're back and nodding your head.
I hope. Well, yeah, thanks so much for taking over for me. So yeah, there is much more to come in terms of implementation, right? So we are using the Hermes plugin to implement the SATP, but again, this is a yet open conversation within the community, right, around this protocol and the standard. So we still need to evolve that implementation so that we can put more layers around the secret asset transfer implementation. We are supporting with the connector right now just Stella Sorba. So we also want to add the start supporting Stella Classic on the connector and a bunch of other things, right? But FIFO, I believe you can go to the next slide and we can use the next minute to go and talk to you folks. I know that we received maybe 2 questions. So Tomas, not sure if you want to bring those questions or if you can just like start answering and inviting people to open the mic.
Yeah, absolutely. So whoever wants to speak up, just raise your hand and I'll unmute you, and then you can ask your questions to Doug and FIFO.
And I think we have one in the
Yep.
Okay, awesome. It's from Alan Hamid. He's asking about could this protocol be applied to a trade or logistic use case using the Solana blockchain? And the answer is absolutely yes. So on the Solana blockchain, you would require a Solana connector that speaks the Solana language and carry on the specifics. You could leverage a lot of the other functionalities from the framework to orchestrate the recipe and all the steps that needs to be done. Of course, you probably create your own flavor of those. So what needs to happen on the blockchain and what needs to happen on the logistics side. And you can simply use the different APIs and ways of connection to connect to your logistic system and what you have in place. So absolutely, it can help you bridge not just blockchain to blockchain, but blockchain to traditional systems and other applications. So yes, absolutely.
Okay, thank you, FIFO. And we do have another question from Jim, I believe.
Oh yeah, he's mentioning the key is the escrow manager for any exchange, so not simple HTLC. So that is a semantic standard that is missing in transaction architecture today. It's all custom work, which is a gap. Yes, absolutely, you're correct. And for those that are not familiar, the HTLC is one approach to how to do these asset exchanges. It's a hash time lock contract. And I highly recommend people have a look. If you're a developer in this session, go have a look. It's one of the creative ways you can orchestrate these on both sides by just using time locks to create a safe time window to act and make this transaction. And absolutely, as we work with these different flavors, there's just so many ways you can build things, in so many ways these can be standardized, that I am really excited to see how we're going to evolve those and tackle in a unified and shared way for everyone. So yeah, thanks for the comment, man.
Yeah, now I see some other questions in chat, actually, if you guys can open that one. It's a
Yeah,
bit
and
of
actually,
feedback.
Thomas, Vikish Patel is with a raised hand for a while, so I'm not sure if you want to unmute and speak your
Let me
question, Vikish.
see. Oh, excuse me, I didn't realize there's a Vikesh. Yeah, of course. There we go. Vikesh, you can unmute yourself.
Hello, can you hear me now?
Hello, yes.
Yes, we can.
Oh, okay, awesome. Hey guys, Vikesh. It says I'm from the US, but I'm actually in India right now. But great presentation. I'm working on projects around tokenization in India on the India stack. I don't know how familiar you guys are with the digital public infrastructure of India, but and they have this idea about Finternet, and it's right along the lines of how, like, I think Hyperledger Cacti could be the thing that they're talking about to create a unified ledger system that can be tokenize assets along different ledgers, like lots of different ledgers. And in India, you already have an identity protocols, and like it's the largest biometric ID in the world. Yeah. So, anyways, I'm not. My question, I guess, is like, how familiar are you guys with the digital public infrastructure of India and how Hyperledger Cacti could fit in to tokenize some of the financial transactions and different things that are happening on the India stack around UPI and stuff. Yeah.
Great point, Vikesh, and thanks for opening up and sharing this.
Yeah.
So I just know through the surface the India ecosystem and how you guys are tackling those and the specifics. But from what you just shared and from what I know about it, I think it's a great match to consider Cacti for this kind of application, because you're not just talking about different infrastructures, but also about the specifics that run in this region, in this regulation. So for example, for the digital identities, there are some approaches already implemented in the Cacti using Hyperledger solutions. But if you need something very unique, you kind of having this open window in which you can create your own connectivity and you bring your own steps to the recipe on how you're going to orchestrate those, what kind of information you're going to be sharing, and how you're going to do that with specific systems that come from other portions. So yeah, absolutely. And even if you're sending those across different organizations tackling specific problems, I think you can definitely use the Cacti framework for leveraging those. I honestly only touched on a few points of the project because we just started interacting with it by the middle of this year. So I didn't even have the chance to look at all the components and all the elements that we have in there right now. But I absolutely believe it would be a great fit, and I would invite you to come to the Discord channel, to the community, and share these specifics with us. I would love to discuss those and learn more about the use case, and I am sure that the whole team would as well. So thanks so much.
Perfect. We
Awesome.
have two
Thank you,
other
guys.
questions. Oh, sorry. Go ahead.
Thank you, and thank you, Vikesh, for your question.
Thanks so much, man.
Yes.
Perfect. We have two other questions, people. We have 5 minutes left on the chat. One's from Alan Hamid about besides Fabric, what other tech stack from could be used from IBM?
Oh, that's good question. I'm not familiar with all the stacks from IBM, but if I think about everything we have on the Hyperledger Foundation, for example, the Hyperledger stack, we can out of the box think about Bezo, which we have already implemented. We can think about Indy for specific solutions with identity, and this is a very rich ecosystem. And not just IBM, but every other entity and other ecosystem can be plugged in some way. That's the idea of the framework. It's agnostic. It's about facilitating this connectivity and not being locked to one technology or one type of entity. So probably you should be able to bring very unique applications into the system and connect through your own custom way. I see we have another one about HTLC for NFT tokens from Rafael. Yeah, and absolutely, man. The HTLC is very good for exchanging very different classes of assets. So if I have, for example, Bitcoin on the Bitcoin network and I want to buy NFT on the Solana network with this Bitcoin, I can do that with HTLC. I'll be locking my Bitcoin with the time locks on the Bitcoin network. And I'll be, for example, using the Solana network to lock the NFT on their side and orchestrating this exchange. Of course, I need smart contracts on both sides, so probably not Bitcoin, the Bitcoin network, but you could do, for example, Ethereum and Solana and so on. And where this doesn't apply, you could think of different recipes or other creative ways of creating these. Let me see what else. I think Jim is commenting from the IBM platforms. Awesome. From IBM platforms, you can use any Hyperledger solution. We've done that. That's awesome, Jim. Thanks for sharing. HTLC has issues with regulatory compliance for many use cases. And that's a good point because it has some strong points and some weak points. And that's something you need to consider when building these use cases because you don't have like a silver bullet that solves all the problems. And sometimes the space on which you're working require specific problems to be solved. So sometimes this might apply, sometimes they might not apply. So you need to consider all the elements of the problem and the space you're trying to navigate before building the solution. So thanks so much for the comment, man. That was well noted.
Yeah, and thank you very much, FIFO, also for answering your questions. We have the questions from the audience. We have 3 minutes left, so if there is one question, if we can address it very quickly, we can do it. Otherwise, you'll wrap up, and then we will share a little bit of we'll share your contact so people can reach you later on if needed.
Yeah, if you can, we have one open question here on the Q&A, which is, it's a great question, but I believe we need more time to expand on top of that. But it's a question about like, can we connect Web 2 and Web 3? So people, maybe we can move to the next slide so that we can show our contacts and maybe briefly talk about these and maybe open a CTA so that we can continue the conversation further.
Yeah, absolutely. Absolutely. As I mentioned that you can have these composable solutions with Cacti, you can borrow its intelligence and its components to handle the Web3 portion and do what it does well. And you can connect it to whatever you have on the other side that is more akin to the Web2. So absolutely, it is completely agnostic. It doesn't lock you just to Web3 solutions. It can be used to connect these two ecosystems. So for example, if you just want to leverage the business logic portion of Cacti, you could do that in isolation with two completely different systems that don't even use Web3. So yeah, absolutely, you can do that. It just might require some creativity on how to bundle the components and select what you need for your specific problem.
Great, thank you so much. I'm really sorry that we have to interrupt this because I see the audience has a lot of good questions. And thank you, Graciela, for sharing the DAX and FIFO's LinkedIn's. I hope you can find it now, Ellen. And you will be able to download this presentation that you're just seeing on your screen from our webinar library, so you can later also find it there. So first of all, thank you so much, Doug and FIFO, for the great presentation you shared. I learned a lot. It was great topics. And for those of you, as mentioned, that we didn't get to your questions, feel free to reach out to Cheesecake Labs directly and get your questions answered there. So just before we finish, I would like to invite you to visit our events page to learn about the upcoming events with the Hyperledger. We have another member from Brazil doing a presentation on September 19. It's the Brazilian Development Bank. And on the events page, you can find the information about both online as well as in events where we are present in person as well. Also, you're welcome to visit our meetup page to learn about the upcoming meetups in Hyperledger Foundation community. And I also posted the link to Discord in the chat, but don't forget to check our Discord. And there's a lot of real-life communication going on there. And you can get more information about the project, special interest groups, original chapters, and much, much more. Also, for those of us that are interested in joining us as corporate members, such as Cheesecake Labs is, you're welcome to contact us at membership@hyperledger.org. Once again, thank you so much to Doug and FIFO for presenting at these webinars. And thank you so much to our audience that has joined us today and post all of these great questions. And don't forget to follow us on LinkedIn and also to join our upcoming webinars as well. Thanks again and see you next time.
Thanks so much. Take care.
Thank you.
Bye.